Hi students! So all last week we were doing linear equations, but simple ones such as y equals 3x plus 6. And we were finding the slope and the y-intercept. With this one, the slope would be 3. Why? Because it always is in front of the x. And just remember, imagine the little skateboard underneath the 3 going up the slope of the x, and that's how you always know that's the slope. And the y-intercept is always following the x. So right here, the y-intercept would be plus 6. And I always want y'all to graph after you find the slope and the y-intercept. So with the slope, you always want to use rise over run. Just always remember that. But with this one, we don't have a run, which is underneath, so just simply put a 1. So now we're going to go over here to our coordinate plane. And first we're going to graph our y-intercept, which is 6. So we're going to go up 6. We're going to rise 3 and go over 1. And you can do that down 3 and over 1. And that is how we do the slope and the y-intercept and graphing it. And that's just a review. But now we're going to go on to the next thing. I want y'all to get out your formula chart and you're going to find point slope formula. Because instead of being given a linear equation, we're going to be creating our own linear equations. So now we have some points and the slope. So we're going to get the point slope formula, which is y minus y1 over x minus x1 equals m, which is our slope. And we're going to just plug in for right now. So we have y minus y1, which is 1, over x minus x1, which is 2, equals m, which is our slope, is 6. Okay, so since we're trying to figure out our point slope formula and create a linear equation, we have to get y by itself. So we're going to go and get y by itself, which y is in the numerator, so we want to get rid of the denominator, and we're going to multiply to get rid of it. And whatever we do on this side of the equal sign, we have to do on the other side of the equal sign. So we're going to multiply 2. And we're going to cancel, and we get y minus 1 equals 6 times x minus 2. And remember PEMDAS, we always multiply first. So we get y minus 1 equals, we're going to distribute 6x minus 12. And since y is still tagging along with that negative 1, we're going to move it to the other side. So we're going to add 1, and whatever we do on this side, we have to do on the other side, plus 1 over here, and we're going to cancel, which we get y equals 6x minus 11. Okay, so just like I told you over there, slope is always in front of the x. So the slope should be 6, and the y-intercept is always falling behind the x, so it's going to be negative 11. And I'm not going to graph, but I want you to graph at home just for practice. But y'all should already know that. But just in case, I want y'all to remember, you can always email me. Okay, so we're going to practice one more time. Our x and y are 3 and 2, and the slope is 4. So we're going to go ahead and plug in real quick. So y minus y1, which is 2, plug it in, over x minus x1, which is 3, plug it in, equals slope, which is 4. And we want to get y by itself, so what we're going to do, we're going to multiply again. Whatever we do on this side, we have to do on the other side. This cancels, and we get y minus 2 by itself. And we're going to distribute this 4x minus 12. Now what do we do to get this y by itself? We're going to add 2 to the other side, cancel, y equals 4x minus 10. And we're going to find the slope and the y-intercept again. The slope is always in front of the x. Remember the little skateboard underneath goes up the ramp of the x because it likes a slope. There's the 4. And the y-intercept is always following the x, so it's negative 10. And then graph your slope and your y-intercept. And always remember, just because the slope doesn't have a run underneath it, it would be 4 over 1 to get the rise over run effect with the graphing on the coordinate plane. And that's it, but please email me if you have any questions at all. I'll see you on Monday.